Technical Introduction to Python Programming course. We're going to continue the first module, which is the basics. Today we're going to talk about math operators in Python. In this class, we're going to discuss about operators, the basic arithmetic operators, order of operations, augmented assignment operators, built-in math functions, practical examples, and we're going to run it up with a summary. Begin with, what are operators? Operators are special symbols that tell Python to perform a specific calculation. Python supports all standard mathematical operations and more. Math operators in Python work on both integer and float values, that's both decimal and floating point values. The values an operator works on are called operands. For example, 5 plus 3 is the operator and 5 and 3 are the operands. Now let's look at the basic arithmetic operators in detail. I have my Visual Studio set up. I have my terminal. So I'm going to switch to my Python shell by typing the command Python. There I have my terminal open. We're going to talk about the basic arithmetic operators one after another. We're going to start with the addition arithmetic operator. The addition operator, just like we know, adds two numbers together. They work on both integers and float values. Mixing an integer and float always returns a float. Now let's see this in practical aspect. So when I type in the expression 5 plus 3, I have my result as 8, and this is because 5 here is an integer, 3 here is also an integer. They are both operands, and I have the addition operator. So this gives me my value or my result as an integer, which is 8. Now when I type in the expression 5 plus 3.0, I have my result this time around to be in float, which is 8.0. That is because I am adding an integer and a floating point value, which is giving me my result as a float value. So you need to know this, that anytime you're adding or carrying out an operation with two different data types, an integer and a float, the result is always going to be a float. Now we can do some other addition operation, such as adding values such as 1000 plus 2000. That gives us 3000. But we can use an underscore as a way to enhance our readability, especially when we are working with large numbers. You can use the underscore to separate large numbers such as maybe 1 million plus 2000, and that gives you 1,002,000. So you can use the underscore as a handy symbol to separate your figures together. So I can equally do 1 million plus 2 million. That will give me 3 million. So the underscore can be used just for readability's sake. Now let me clear my terminal. Next, we're going to talk about the subtraction operator. The subtraction operator subtracts the right operands from the left. The minus symbol also works as a negation operator for a single number. Now back to our shell, we can subtract 4 from 10. That's going to be 6 as expected. We can also do 3.5 minus 1.2, which is going to be 2.3. So in this case, as you can see, both operands are floating values, so the result is also going to be a float. In the same way, when you subtract an integer such as 10 minus 4.2, of course your result is going to be a float as well. Now we talked about the negation. So the minus symbol can be used to negate a value. So this is negative 10. You have positive 10 and use the minus sign to negate it to a negative 10, and that is it for the subtraction operator. Now next is the multiplication operator. The multiplication operator multiplies two numbers. It also works for string repetition, but in this class we are not going to talk about strings. We're going to cover that in our subsequent lesson when we get to that. You can multiply two numbers such as 6 multiplied by 7, which gives us 42. We can also multiply mixed numbers such as 3 multiplied by 1.5, that will give us 4.5. We can also multiply an integer and a negative integer such as 2 multiplied by minus 4, which is going to give us a minus 8. So we can do all sorts of operation that has to do with multiplication using the multiplication arithmetic operator. You can also multiply number like 3 multiplied by 5, that will give us 15, and so on and so forth. The true division operator is a slash, single slash. So what true division does it actually returns a float even if the result is a whole number. So we use the slash when we want to or when we want the exact decimal result. Let's see this in practice. Now when you say 6 divided by 3, mathematically we know the answer is supposed to be 2. But since we are using the true division operator, it's going to return our answer as a float, even if the result is supposed to be an integer like this. So you can also carry out an operation such as 7 divided by 2, which is going to be 3.5 as expected. And we can do some other sort of operations such as 4 divided by 2. This is going to give us 2.0. So the result of a true division operation is always going to be a float. Next, what we have is the floor division. The floor division sign symbol is the double slash, and it divides and rounds down operation to the nearest whole number. The floor division is also called an integer division. That is because it always drops the decimal part. Floor in this case means that it always rounds down towards negative infinity and not towards 0. Now let's look at this in practice. Now in this case, when we use the double slash or floor division and we say 7 divided by 2, our answer is going to be 3. So you can see earlier when we were using the true division, we had our answer or our result to be 3.5. But this time around, since we are using integer division or floor division, it drops the decimal part and returns only the integer part. So we can also do 6 divided by 2 as we did earlier, and this time around we'll have only 3. So that is the difference between the true division and the floor division. The true division always returns a float, while the floor division returns an integer, dropping the decimal part. Now next we have the modulo operator. The modulo operator is represented with the percent sign. It returns the remainder of a division operation. The modulo is extremely useful in real programs, just like checking for even number, divisibility, or maybe cycling through values. Now let's look at this in practice. When we say 7 modulus 2, our answer is going to be 1. Now we can also do 10 modulus 5, which is going to be 0 as expected, because the remainder of 10 divided by 5 is 0. There is no remainder. So when we do 11 modulus 5, we can see the remainder is going to be 1. Next, we are going to talk about the exponentiation, which is represented by 2 asterisks. The exponentiation raises a number to a power, and it works with negative and fractional exponents too. So let's try this out at our shell. We have 2 exponent 8, which gives us 256. We have 3 exponent 3, which gives us the cube, which is 27. We have 10 exponential 6, which will give us 1,000,000. We can also raise a number to the negative number, which we have 2 exponential minus 1 will give us a 0.5. We can also raise 9, which can also raise 9 to the power of 0.5, which is a fractional exponent, is going to give us the square root, which is 3.0. Python actually handles large integers, just like we saw earlier. So when we raise 2 to the power of 100, that should give us a large integer number there. And this is very convenient for our Python interpreter. Now let's talk about the order of operations, or another way we call it the order of precedence. That is, which operator is going to be executed first before another when you have a stack of different operators in an expression. So we say Python follows standard mathematical order of operations. The first one we have is PANDAS. P stands for parentheses, E stands for exponents, the M stands for multiplication and division, while the A and S stands for addition and subtraction. You can use parentheses when we are in doubt, and maybe when we want to make our intent explicit and our code readable. PEMDAS is a standard which Python also follows. So what this actually means is when you have a compound expression such as 2 plus 3 multiplied by 4. This gives us 14 because multiplication comes before addition. So it first of all multiply 3 by 4, then it adds the result, which is 12, to 2, which makes it 14. The next, we can add parentheses to make our expression clearer. 2 plus 3 multiply by 4. So you can guess. So using our pandas, you can see parentheses will come first, then multiplication will follow. So you can see here we are distinguishing this operation from this, but they actually look the same. But with the presence of the parentheses, this time around, the interpreter is going to execute this first because execute parentheses before any other operator. So this time around, what you're going to have, you have the addition of 2 plus 3, which is 5, then multiply by 4, which gives us 20, as you can see. So we can also do some other expressions, such as maybe 2 exponential 3 exponential 2. This time around, exponentiation is right associative. That means it begins from the rightmost side, which is 3 exponential 2, then it now carries out 2 exponential, the result which you have by your right. Because exponentiation is right associative, it starts execution from the right, which is 3 exponential 2, which gives us 9, then it carries out 2 exponential 9. So if we execute this will give us 512. Now, to make this more explicit, we can also use the parentheses and say 2 exponential 3 in parentheses, then exponential 2. So this time around, parentheses changes the order of execution because it's going to be observed executed first, carries out these 2 exponential 3, then which is 8, then 8 exponential 2. So this is going to give us 64. So next we're going to talk about augmented assignment operators. These are just shorthand operators that perform an operation and assign the result back. So it's just a way of making our code snippet cleaner and more Pythonic than writing the full expression. So we have a lot of them here, but I'm just going to talk about a few from them because it applies C to the rest. Now let's look at the first shorthand here. Okay, let's start with a variable. Let's declare a variable, let's say score, which is equal to 10. So we have our value 10 stored into the variable score. Now let's look at the first shorthand operator there, which is plus equal to. The first plus equal to. So I can, instead of saying score is equal to score plus maybe another value such as 5, which is okay, let me print this so you can see the value score, which is 15. So instead of writing this longer expression, I can use this shorthand operator here and say score plus equal to 5. That will give me 15 again. Okay, sorry, this time around my score value has already been altered here, so I have 15 already. So score plus equal to 5 means score is equal to score, which is 15 plus 5. That's why we have 20 here. So if I do this again, score plus equal to 5, you can guess what the answer is going to be. This is going to be 25. So there we have it. Now we also have, okay, we have our value of 25 stored in score. Let's look at the second operator, shorthand operator, which is the subtraction. So we can equally say score minus equal to 5. So you can guess what the answer here is going to be. That was going to give us 20. So it's the same thing as saying score equal to score minus 5. This time around, we have 20 already. That's the last record of our score. So this time around, we're going to have 15. So this is the same as all other augmented assignment operators you see here. So you can see the example. So x is equal to x plus n is same as x plus or equal to n. So that's what this means. You can see some of them here, and you can see their examples here. So you can follow this and It makes your code more cleaner and more Pythonic rather than writing the full expression. So that is it about the math augmented assignment operators. Next, we're going to talk briefly about some built-in math functions. The first one we have there is absolute. So absolute here is a function. This is an example. So it returns the absolute value of whatever you're passing into the abs function, be it a value, be it an expression. If we look at this, now if I type abs -7, this is going to return the absolute value, which is 7. Now you can equally type an expression, maybe the result is a negative. It's going to return the absolute value of that result. So if I say 3 minus 6, which is going to be -2, which is going to be -4. So passing this into the abs function gives me the absolute value of this expression. So instead of -4, I'm going to have now let's look at the abs function. So if I pass the value into abs function, say -7, this is going to give me the absolute value, which is 7. I can also pass in an expression such as 3 minus 6. So this is supposed to be -3, but since I'm using the abs function, it's going to return an absolute value of -3, which is going to be 3. Now the next function I have is the round function. The round function, just like the name implies, it rounds a number to the nearest integer. If I pass 3.7, it's going to be 4, rounding 3.7 to the nearest integer, which is 4. I can equally pass floating number 14159, and then I can pass in an additional argument which is going to specify the number of precision I want rounded up to. So I can pass 2. It means that I need this number to be rounded to 2 decimal places. So this 2 here specifies that. So this is going to be 3.14. Now the next function I have is power. You can raise a number to its power. So you can say 2 raised to power of 8. So this is 2 raised to power of 8. So as you can guess, the answer is going to be 256. Next we have the max function. The max function returns the largest value in a list or a set of numbers. So if I pass this 3 number to the max function, it's going to return the largest value, of course, which is going to be 7. Then we have the last, which is min, returns the smallest value. In this case, this is going to be 1. So that is it about the built-in math function. This is just basic review of what these functions can actually do. Now let's look at some practical examples quickly before we round up this class. We're going to talk about we're going to write a little snippet right here from our Python shell, how to calculate the area of a cycle. To calculate the area of a cycle, we need 2 variables. The first variable is going to be our radius. The second variable is going to be area, which is going to store the result of our calculation. So we need 2 variables. The first is going to be our radius. So I can define a variable radius and assign 7 to it. Then we need to define a variable area. Now what is the formula for calculating the area of a cycle? Of course it is pi multiplied by radius exponential 2. So our pi, 3.14159, multiplied by radius. So we have our radius already defined, which is 7 exponential 2. So that is the formula for calculating the area of a cycle. Now all we need to do is to print out the value of our area, and this is going to be 153.9379. So there we have our little program to calculate the area of a cycle. Next, let's look at converting minutes to hours and seeing the remaining minutes. So in this case, we want to convert minutes to hours and, if possible, the remaining minutes. That is, if there is. So Let's say we have a total minute as a variable. So we have our total minute as 137 minutes, and we need to calculate how many hours there are in 137, and if possible, how many minutes will be left. So we have our first variable, which is the total minutes. Then we need to define our hours variable, which is going to hold the number of hours in that minute. So the value of our minute is total minutes. So we are dividing this by the floor division or integer division by 60. So 60 minutes makes an hour. So we are taking the total minute, dividing it by 60 to get the number of hours in our total minute. So that is for hours. Then we're going to check if there is a remainder left after checking for hours in our total minutes. So we are going to define that as minutes, and then we're going to say total minutes. So this time around, you can see we can use the modulus operator here. We can say total minutes modulus 60. So when you divide the total minutes by 60, how many minutes is going to be left? So that's going to be our minutes. Lastly, we can print this out. We can say we have hours. You can say print hours. We separate each with a comma, and minutes. So we have it. So there we have it. We have 2 hours and 17 minutes. So we can print this in a more fancy way by typing print. So we can use a f string. We will look at this when we talk about our strings, but for now, just know. So I can use my f formatted string to say f. So I will pass the value of hours in r, then pass the value of minutes in our curly brace, minutes, and there we'll have it, 2 hours 17 minutes. So that is it about this example, and well, I'll leave the 2 examples for you to check that up. You can equally write a little program or a simple program to check if a year is a leap year, and a simple interest calculator. Thank you very much, and that is going to be all for this lesson.